In working this exponential problem, you'll want to treat it as three separate problems or three separate fractions. First, reduce the fraction -6/14. Each is divisible by 2, so that's going to be a -2, and then each is divisible by 2, so that's going to be -3, and then 2 goes into 14 7 times. So -3/7 is -6/14 reduced. Then you have x to the positive 4 on top, x to the positive 1 on the bottom. So that's like having 4 x's on top, but only 1 on the bottom. So when I go through to cancel an x for an x, I still have 3 of those x's on top. If I do the same for the y's, and again, this works when the variable has a positive exponent on it, I can actually write down that I have 2 y's on top, but I have 4 y's on the bottom. So again, if I cancel a y for a y, 1 on top with 1 on the bottom, 1 on top, 1 on the bottom, I'm left with 2 on the bottom. So as a final answer, I would write up the -3, and then I have x to the third, that's 3 x's, over 7, and then you have 2 y's on the bottom, or y squared. If any of these original exponents are negative, you'll want to write them or rewrite the fraction with positive exponents before doing this counting and crossing out of the variables. But in this case, that will be your final answer.